Let's discuss about acceleration. As I think in your earlier classes, you might have covered that acceleration is rate of change of velocity. But here we define acceleration as an instantaneous term. Say for example, a particle starts from a point and moves in the positive direction of x-axis. Say at any general instant of time t, the particle is having a velocity v. And in a very short duration from t to t plus dt, so the velocity is increased from v to v plus dv. So we can say in a duration dt the velocity increment is dv. Then in this situation at this time t, as dt is very small neighborhood of this time t, we can write acceleration time t can be given as this dv by dt. This is the instantaneous acceleration at time t. This can be simply written as time derivative of velocity vector. Vectorially, we find acceleration vector is dv vector by dt. And it can also be written as a slope of velocity versus time curve, because dv by dt is the slope of vt curve if we are finding the acceleration for a body moving in rectilinear motion. From here we can also analyze one thing, as we have studied, if we are having displacement, if we differentiate displacement we get velocity. If we differentiate velocity with respect to time we get acceleration. And vice versa is also true. When acceleration is integrated we get velocity, and when velocity is integrated we get displacement. We are going to discuss several applications or examples based on this concept. Like here instantaneous acceleration we can also give as dv by dt, or if we write velocity as dx by dt, or velocity is the differentiation of displacement with respect to time. So we can write acceleration as second differentiation of displacement with respect to time, that is d square x by dt square. There is one more way in which acceleration can be written, like if it is expressed as dv by dt, which is multiplied by dx and divided by dx. So here you can see this dx by dt, this dx by dt can be written as v into dv by dx. This is another way of expressing acceleration as velocity multiplied by slope of velocity displacement curve. Here we can see acceleration is the slope of velocity time curve. Here you can write acceleration as instantaneous velocity multiplied by slope of velocity versus displacement curve. This is another way of finding the acceleration. As we have seen that acceleration can be given as dv by dt, or it can also be written as v dv by dx. Say this is equation 1, this is equation 2. Both the equations are having their own importance, like if acceleration is given as a function of time, then we use equation 1, because here you can see acceleration is expressed in terms of velocity as well as time. Sometimes it happens that in various problems, if a is given as a function of displacement, then obviously here we are going to use equation number 2, because here you can see in equation 2 acceleration can be expressed at velocity as well as displacement. Sometimes it may happen that if a is given in terms of velocity, then we can use either equation 1 or equation 2, which basically depends on the requirement of data in the problem or whatever is required in the problem. Based on that we are going to use equation 1 or 2, whether it is related to time function or it is related to displacement function. That will be more clear with the help of some examples. Let us take up one example here only. Say if for a particle its displacement is x is equals to 3t cube plus 2t square plus 5t plus 6 meter. Here you can see the displacement is given as a function of time, and say we are required to find acceleration of particle at t equal to 1 second. So if we are required to find the acceleration, we need to differentiate it twice. Like if this is the displacement, here we can calculate instantaneous velocity as dx by dt. So if we differentiate it, it will give us 9t square plus 4t plus 5. It is in meters per second. And if we find out acceleration, it can be further given as dv by dt. So once again we differentiate it, it will be 18t plus 4 meter per second square. So here we are required to find acceleration at t equals to 1 second. That 1 second acceleration can be given if we put t equals to 1, it is 18 plus 4, that is 22 meter per second square. This will be the answer to this question. Now we are going to discuss about average acceleration. We can simply state for a motion of particle between two instants, its average acceleration can be given as, average acceleration is defined as, it is defined under this symbol, it is total change in velocity divided by time taken. If velocity is changed by delta v, we can simply write it delta v vector by delta t. This is the average acceleration. So if a particle velocity changes from v1 to v2 in a time t1 to t2, it can be written as v2 minus v1 vector divided by t2 minus t1. This is the way how we directly find the average acceleration. For average acceleration, we don't need the way how velocity is varying, how it is changing. We just need the velocities at initial and final instants. Just to understand it, we take up here an example. Say, if a truck moving at 4 meters per second toward south, a truck is moving in south direction at a speed 4 meters per second, takes a turn toward east, and say its velocity changes to 3 meters per second. If turning time is 10 seconds, we are required to find the average acceleration of truck. So this is the question we need to solve. In this situation, once again, if you just have a look, the truck was initially moving at 4 meters per second towards south. So if we talk about this v1 vector, v1 say it is the initial velocity, it is 4 meters per second towards south, say it is moving in the southward direction. And it takes a turn toward east. So final velocity v2, which becomes finally 3 meters per second, it is toward east. And we are required to find the average acceleration. So here average acceleration can be written as it is v2 vector minus v1 vector divided by total time taken as 10 seconds here. So v2 vector minus v1 vector, either we can find out by using velocity triangle or vector triangle, like say v2 vector is in this direction, if v1 vector is in this direction, so minus v1 vector will be in this direction. So resultant would be this. You can say this is 3, this is 4, so this will be certainly 5. So if we substitute the magnitude of this v2 minus v1 vector, the magnitude of acceleration can be given as 5 by 10. So here in this situation, it will be 0.5 meters per second square. If we wish to find out its direction will be toward, you can simply state if this is the east direction, it will be north of east at an angle theta. and here tan theta can be written as 4 by 3. That means theta will be 53 degree. This will be in direction 53 degree north of east. You can simply state from the direction of east, it is at an angle 53 degree toward north, and the change in velocity v2 vector minus v1 vector is 5. So v2 minus v1 is 5 and time taken is 10, so 5 by 10. The average acceleration will be 0.5 meters per second square in a direction 53 degree north of east.